Okay. A certain will come up with one problem. In problem shows a certain data source has 8 symbols that are produced in blocks of 4 at a rate of 500 blocks per second. The first symbol in each block is always same. The remaining 3 are filled by any of the 8 symbols with equal probability. What is the entropy of this source? What is the entropy of this source? Okay. Solution for that problem. Here, a block of 4 symbols can be illustrated as shown in figure below. And he says that there are 8 symbols, that is q is equal to 8. And he says that the symbol rate is 500 blocks per second. First 4 blocks are there. The first bit is the synchronizing bit. The symbol are produced in a block of 4. The total entropy is ht is equal to h1 plus h2 plus h3 plus h4. The first bit is always same. See, whenever there is always same, no information is carried out by the show unit, and hence h1 is equal to 0. Given that the second position is occupied by one of any of the 8 equiprobable symbols, we have h2 is equal to h of s maximum. Okay, so that log q to the base 2 is equal to q is equal to 8 here. So substituting that, we'll get 3 bits per message symbol. Since third and fourth positions are also occupied by any of the equiprobable symbols, we have h3 is equal to h4 is equal to 3 bits. Therefore, the total entropy is the summation of all this. However, h1 is 0, h2 is 3, h3 and h4 are 3, so that total entropy is 9 bits per blocks. Okay, entropy rate is equal to information rate. Entropy rate is nothing but the information rate, capital RS. It is given by small rs into ht, where ht is the total entropy, rs the symbol rate, and rs is given 500 blocks per second into the, just now we have found the total entropy, that is 9 bits per block. Totally the information rate or entropy rate is 4500 bits per second. Okay, another problem. It says that a black and white TV picture consists of 525 lines of picture information. 525 lines of picture information. Assume that each line consists of 525 elements, picture elements, and that each element can have 256 brightness levels. Pictures are repeated at the rate of 30 frames per second. Calculate the average rate of information conveyed by TV set to a viewer. Okay, the block diagram shows they have the 525 horizontal lines are there. Each horizontal line have the 525 pixels, and each pixel will have 256 brightness levels. Okay. Total number of pixels in one frame. 525 horizontal lines, and each horizontal line will have 525 pixels. So 525 into 525, that is 2,75,625 pixels. It is given that each pixel can have 256 different brightness levels from fully black to fully white. Then the total number of different possible frames possible are 256 to the power of 2,75,625 frames. Let us assume that all these frames occur with equiprobability. The net maximum information content is h of s maximum is equal to log q to the base 2. What is q? Q is equal to total possible pixels. So that is 256 to the power of 2,75,625. And as we know that log m to the m to the power of n is nothing but n log m. Okay, with this we get I is equal to 22.05 into 10 raised to 5 fifths per frame. It is given that there are symbol rate 30 frames per second. Average rate of information is given by rs is equal to small rs into I or h of s, but since they are equiprobable, I is equal to h of s. So 30 into 22.05, substituting all this, solving, we get rs, the information rate or average information rate is 66.15 into 10 raised to 5 bits per second. Okay, here is one formula to derive. Okay, suppose that S1 and S2 are two zero memory sources with probabilities P1, P2, P3 up to Pn for source 1 and Q1, Q2, Qn for source 2. So that the entropy of source 1 h of S1 is equal to summation of k is equal to 1 to n pk log 1 upon qk. Okay. Here S1 and S2 are zero memory information sources. Okay, h of s, the entropy of h of s1 will be completely of pk. So it has been given summation of pk log 1 upon pk, and we know that the total probability, the sum of the probability of any event should be is equal to 1. So that summation of pk is equal to 1 for k rise from 1 to n. Similarly, for symbol 2, h of s2 is equal to summation of k is equal to 1 to n qk log 1 upon qk. Pk is the probabilities of s1 and qk is the probability of the s2. And again, qk, the total probability is always should be is equal to 1. Consider h of s minus, okay, consider this equation h of s minus, okay, log 1 upon pk. Okay, and we know that h of s is equal to h of s1 is equal to summation of pk log 1 upon pk. Subtracting both on same element, that is k is the summation of k is equal to 1 to n pk log 1 upon qk. Substituting on both sides, subtracting both sides, and simplifying this, we get the equation as shown here. See, here we have that the logarithmic curve always lies below the straight line. The logarithmic curve always lies below the straight line. Because of that, we have this equation saying that ln of x less than or equal to x minus 1. X minus 1 is the equation of the straight line. Ln of x is the equation of the log curve. With x is equal to qk by pk, substituting this and solving, we get as shown here. Simplifying this, we get as shown here. Okay, finally we get h of s1 is equal to summation of k is equal to 1 to n pk log 1 upon k. Okay, this is the theorem, so we supposed to be proved and already solved, and pdf is will be provided. Okay, another problem: find the information content of a message that consists of a digital word 9. It's long, in which each digit may take one of 5 possible levels. The probability of sending any of 5 levels is assumed to be equal, and the level in any digit does not depend on the value taken by the previous digit. Okay, we'll solve that one. The length of the digital word, the 9 digits. We have got the digital word which consists of the 9 digits. Number of levels is equal to 5 equiprobable. The digital word 9 can be illustrated soon. Digit 1, digit 2, we have up to 9 digits. So the total entropy Ht is equal to H1, H2, H3 up to H9. Sorry, that is H9, where Hi is the entropy of the ith digit, where I is equal to 1 to 9. Since each digit can take take on any of 5 equiprobable levels, each we have h is equal to h of s maximum. 5 equiprobable levels, so log q is equal to log 2 to the base 5, log 5 to the base 2, we will get 2.322 bits per level. So total information content ht is equal to 9 into 2.33, so that 20.898. Another problem. A pair of dice are tossed simultaneously. Die is tossed simultaneously. The outcome of first die is recorded as x1. The outcome of the first die is recorded as x1, and that our second die is as x2. Two events are defined as follows. Now the events are defined as follows. The event number A. He says that the you have to consider the events such that x1 and x2, the summation of that should be less than 7. And B, second event is x1 comma x2 such that x1 is greater than x2. Among these two events, which event conveys more information? The question asked is, among these two events, which information conveys more information? Support your answer by numerical computation. She says that you have the pair of dice, it tossed 2 times. Okay. One die we have got once we toss a die means we got the 6 possibilities. 1 to 6 we can get. Since we got the pair of die, so 6 into 6, 36 possibles we can get. Totally 6 into 6, 36 possibilities we can get. He says that x1 is the values recorded from the dice 1, x2 is the values recorded from the die 2. He says that there are 2 events. First event, we have to consider that the summation of x1 and x2 should be less than or equal to 7, and the second event is x1 is greater than x2. Among these 2 events, which event conveys more information? Support that through your mathematical or numerical concept. See, here I have given s is equal to 1 comma 1. Once I toss means I can get both die, I can get 1 comma 1, 1 comma 2, okay, like that. Totally we got 36 combination of such that. First one is x1, this is x1 and this is x2. Okay, totally there are 36 combinations are there. So that the possibility of occurrence of each event or probability can be written as 1 by 6 into 1 by 6, that is 1 by 36. Once I toss means I can get one both die I can get 1 only or 1 6, whatever that, the possibility of occurrence is 1 by 36. So as per event A contains whatever event is said, the x1 plus x2 should be less than or equal to c. See, 1 comma 1, x1 plus x2 is 2, 2 is less than 7. So it has been taken. 1 comma 2, 1 plus 2 is 3, 3 is less than 7, it has been taken. See, what all in this event, what all the values of x1 plus x2 which is less than or equal to 7 has been recorded. Which is less than or equal to 7 is going to be recorded. So that how many are there? There are 21 possibilities are there. 21, if you count all these, 21 possibilities are there. Among 36, we will get x1 plus x2 less than or equal to 7, we will get 21 possibilities. So that the probability of A is equal to 21 by 36. 21 by 36 is nothing but 7 by 12, means 21 goes by 3 as well as 36 also, so that 7 by 12. Similarly, and the event, what the event says, x of 1 greater than x2, means you have to record the conditions, cases where x1 is greater than x2. See, x1 2, x2 is 1, so 2 is greater than 1, that is noted. x1 is 3 in the second. Okay, x1 is 3 and x2 is 1. So x1 is greater than x2. Again it is noted. And 3 comma 2 x1 is greater than 4 comma 1 x1 is greater than. So with this we get 15 conditions. So P of B is equal to 15 by 36. So that this can be written as 5 of 12. So self information of event A, IA is equal to log 1 upon PA. Substituting that we get 0.766 bits. Similarly, self information content of B is equal to IB is equal to log 1 upon PB. The information content is 1.236 bits. See from this, see the IA is equal to 0.776 bits, I2 is equal to 1.263 bits. Means that IB conveys more information than that of the IA. The event B conveys more information than that of the event A. Okay. Similarly, next problem. Discrete message source S emits two independent symbols X and Y. Discrete message source S emits two independent symbols X and Y with the probabilities 0.55 and 0.45 respectively. Calculate the efficiency of the source and redundancy. Okay, P of X is equal to 0.55 and P of Y or Py is equal to 0.45. The entropy function is given by H of S is equal to summation I is equal to X to Y, Pi log 1 upon Pi. Okay. On solving that one, H of S we get 0.9926 bits per message symbol. The maximum entropy is given by, see H of S maximum, it is one of the property of the entropy, that is log 2 to the q. Q is the possible symbols. Okay, number of symbols. Q means the number of symbols, maximum number of symbols. Here in this problem, they have got only two symbols, x1 and x2, so that log 2 to the base 2 is equal to 1 bits per message symbol. So source efficiency is given by, source efficiency is equal to H of S divided by H of S maximum. H of S is obtained by putting the probability, and H of S maximum is obtained by with number of symbols. Okay. So 0.9928 divided by 1, it is 99.28%. Source redundancy, okay, that is given by 1 minus source efficiency. So 1 minus 0.9928 is nothing but 0.0072, or source redundancy is 0.72%. 0.72%. Another problem. Shortly before a horse race, a bookmaker believes several horses entries in the race will have the following probability of winning. See, have given the different horses RC, RB, RC, RD and RC, and he says that the probability of winning of RC is 0.44 and B is 0.42, C is 0.31, D is 0.12 and E is 0.11. Okay. E then receives a message that owing to a major injury, one of the horse is not participating in the race. One of the horse is not participating in the race. Explain how would you assess from an information theory point of view the information value of the message. What the question says that there are 5 horses. The bookmaker know that among the 5 horses A, B, C, D, E, and he know the probability of winning that horses. But now he came to know that one horse is not participating. Then how you come to know that? How you with respect to information theory point of view, how you convey this message? If horse is in the question is known, if I know which horse is not participating, if it is not, and second sub question is if horse is not known, the information value of the message where horse in the question is no nothing but the self information. If horse A is not running, then the self information of the message is IA is equal to 4.66 bits. Similarly, if horse B is not running, IB is equal to 1.252 bits. If RC is not running, IC is 1.69. If RD 3.059. If RC 3.184. Okay. The information value of the message, which the R's in the question is not known. Okay, nothing but the average information rate. Okay, is nothing but the average information rate. So h of s is equal to summation of I to a to e. Yes, see, this is only say numerical, only for okay. For simply, I assume that I vary from a to e. That is p of a log 1 upon p of a, p of b plus log 1 upon p of b. Substituting all these, we get 1.953 bits per hour. 1.93953 bits per hour. Okay, another problem. In a facsimile transmission of picture, there are about 2.25 into 10 to the power of 6 pixels per frame. For a good reception, 12 brightness levels are necessary. Assume all these levels are equally likely to occur. Find the rate of information if one picture is to be transmitted every 3 minutes. What is the source efficiency of this facsimile transmitter? Okay. The total number of pixels in the one frame is 2.25 into 10 raised to 6. Number of brightness level is 12. Total number of different frames is nothing but 12 to the power of 2.25 into 10 raised to 6. Since all levels are equiprobable, whenever they are equiprobable, then equally likely to occur, the net maximum information content per frame is I is equal to h of s maximum. That is log q to the base 2. Q is nothing but total number of different frames. Substituting that, we get I or h of s maximum is equal to 8.066 into 10 raised to 6 bits per picture. And he says that the symbol rate is 1 picture per 3 minutes. 1 picture per 3 minutes is nothing but, see, always symbol rate should be in the seconds. So 3 minute is converted into second, that is nothing but 1 by 3 into 60 pictures per second. So average information rate Rs is equal to h of s into small rs. So with this we get Rs is equal to 44812 bits per second.